Hi everyone, Engineer Liu here. So we're back to another C programming language tutorial. And for this tutorial, I would like to talk about string manipulation, see how we can achieve that. If you want to take a look at what is available, we're gonna use the library string.h, which has a lot of functions available built in for us to use in the C standard. But you can check it with man, which stands for manual, right? Man string, and then you have this tons and tons of string functions. Some of them are useful, some of them are utilized, others are less utilized. So, for example, let's take how do we compare two strings? How do we check if two strings are equal to another? String concatenation, check if a certain char is a string. Compute string length, copy one string into another, and so on. Parsing of a certain char, and parsing of data, and yeah. So yeah, let's try some of these functions, right? So we are on the tutorial 14th tutorial, and we start with example A20. Okay, so our boilerplate code, standard IO, we include string.h and perhaps a standard library, but no, I guess just so in main, and okay, so return 0. So first things first, I guess we could start with how do we compare two strings in C, right? So let's say we have a char string 1, which will be equal to I don't know, test1, char string 2, which will be equal to test2, and then string 3, which will be equal to let's say test1. Okay, so yeah, how can we compare two strings in C to see if they are equal? Okay, so we can use if you come from another language such as Python, you might be tempted to do something like this. I don't know, if string 1 equal to string 2, we print string 1 is equal to string 2, else we can use then string 1 is different than string 2, right? Okay, so what do you think will happen on this case? It will work? It will what you want? Well, we know that both strings are different, so we expect then the program to say to us that both strings are equal, right? So yeah, let me check if there are any warnings, and yeah, init variable. Okay, so never, that doesn't affect us, and we got that they're different. Why is that? Any ideas? Well, actually here, if you think about it, what we are actually comparing here are the pointers. Okay, So we're checking if those pointers are equal, and evidently they're not. So if we wanted to check that these strings are equal to one another, we should use something like string compare. Okay, so string 1, string 2. So if string compare is equal to 0, that means then they are equal unless they are not. Okay, so let's compile, run. We're getting yeah, they're different. So let's test it with string 3. We compile and run, and they're equal. And what would happen if actually we used string 1 and string 3, which are, you know, equal? Okay, we will get, yeah, they are actually different, right? So here is string 3, and we can just leave this here and test 1. Since we won't use for now another string, so this is expected, as I've talked, that to be different since there are different pointers in memory. And but if let's say we had a third string, okay, and we make it point to string 1, and let's say if we try something like this on this variable. Okay, so here you got my points of what I was talking about. Here, since we made string 3 points to string 1, then of course they are pointed to the same address in memory, and so they will be equal, right? So that's not what we want, right? We want to see if two strings are equal. So how string compare works is that we have two strings that we compare, right? And then it checks for its value, right? They compare each character by character, and then if they all match, it returns 0, and that means they're equal. Okay, so that's the thing that you have to, if you're coming from another language such as Python, Java, which has operator overloading, such as C++ as well, you might find it strange, right? And let's check what it returns actually, if they're different. So let's print the return. It's integer, right? So return value of string compare, it's an int, so string compare string 1, string 2. Okay, so compile, run. Okay, so here it will be 0, but let's test if they're different. Okay, so let me see, let me show you what it returns. So it returned -1. Okay, so if we check for a manual for string compare, actually a negative value means if string 1 is less than string 2, and a positive value if it's greater. Okay, I believe we would take yeah, it's the comparison is done using unsigned characters. Okay, and right. So let's say we want to concatenate two strings. Okay, so let's make them okay, let's leave it like that. So we use this function called before I get into that, also, if you're coming from a language which has operator overloading such as Java, C++, Python, you also may be tempted to do something like let's say we have a char string, okay, a string 3. Let's make it with I don't know, 200 and no, that's too much. Let's leave it to 32 characters, okay? And you might be tempted to do something like this: string 3 equals string 1 plus string 2, right? That's what you would do to concatenate the strings in Python, Java, and so forth. And then we print the contents of string 3 like this. And yeah, that's what we would do, right? Do you think that will work in C? Yes, no? Okay. So there we go. We try to compile this, and the compile tells us that these are invalid operands to binary char and char, which are strings. Okay. So C doesn't understand that. That makes absolutely no sense to C. And what we have to do to concatenate two strings is to use a function called string_cat. Okay. So basically how it works is that the string_cat appends a source string. Okay, so it will move the source string, the second argument, to the destination string, and it will overwrite the terminating null character at the end of destination string. Yeah, okay. The strings may not overlap, and the destination string must have enough space for the result. This is very important, okay? So let's say you are trying to concatenate a string to another, but the destination string does not have enough bytes available, and that may cause buffer overflow. Okay, so you have to be careful with that. If the destination is not large enough, program behavior is unpredictable. Here we go. Here we have unpredictable behavior, and you basically can get hacked. Okay, buffer overruns are a favorite avenue for attacking secure programs. Okay, so as you can see here, the return value for string_cat is actually a string. Okay, so yeah, it will return the destination string for string_cat. Okay. Yeah, so let's try it. Okay, but we have to make some adjustments. Let's say that our string 3 is actually a string with no characters whatsoever. Okay, so what we want to do here is we have to string_cat. First we append string 1 to string 3. Remember, it's our destination. And then we append string 2 to string 3. Okay, so that's how we would do it, how we would do in C. Okay, so string 3 equals string_cat, string 3, string 1, and then string 3, and then we print the contents of string 3 and assignment to expression with array type. Oh yeah, So what we have to do here, we have to turn this into a pointer. And if you remember from the last lecture, we've done some memory allocation, right? So we have to prepare this to receive. So for that we will need a standard library of C. And yeah, so we allocate memory for it. So string3 equals, we cast it into a char pointer, and then malloc, let's say 32 bytes. I guess it's enough. 32. We can do it like that because we know one char is equal to 1 byte. But if you're I don't know, paranoid or something, or want to keep it to a standard, we use size of char. But we know size of char is 1 in basically most machines over there, and then we got 1, and then you have 32 bytes. So yeah, for the sake of maintaining a sort of pattern in using malloc, you can yeah, use it like that. And then once we're done with it, we free our memory. Okay, free string3. So yeah, let's go with that and compile and run. Where is it? Yeah, so there we go. There we have our string concatenated. Test1, test2. But as you may recall, you have to make sure that string3 has enough bytes to accommodate both strings, right? So that could be a problem. Let's say we have a total here of 10 bytes plus the new character, like 1, 2, 3, 4, 5, and then 10. Let's say we only have 8 bytes available. What will happen? And we compile and run. Yeah, apparently it didn't break our program, but you may end up overriding a part of a memory that, yeah, you shouldn't be overriding. So let's check, for example, just 4 bytes memory allocated. So yeah, still didn't break our program, but you have to be very careful with that. So to avoid doing things like that, C provides us with a safer version of that function, which is string and cat. So this function, it's very similar to a string cat, string concatenation, but this one checks if yeah, it will use the most n bytes from source, and then okay, it does not need to be null terminator. Okay, so if source contains n or more bytes, string concatenates n plus 1 bytes, and therefore the size of that must be at least string length of the destination string plus n plus 1, which will be yeah, the number of bytes plus 1 for the new terminating character. Okay, so yeah, okay, so this argument here is the number of bytes that we want to use. Okay, so thread safety, program source, it will use a knows n bytes from source. Okay, so here you can pass as argument the number of bytes or the string length of source. So in case it goes beyond that, then I believe it won't work. So let's try it out. So let's say string and cat, and here also, and let's try it with 32, and then we use also another function from the string.h library, which is string length, and then we take the string length of we use 32 on this case, which is the number of bytes allocated, and let me go with that unsigned int num bytes, so I don't have to overwrite it everywhere. Let's just call n for the sake of simplicity. So n here, and then n here, and here also n, and I believe that's correct. So yeah, it works just like before. But let's see what happens if we set it to 8 and we try to write more than I believe then we have an error, and it worked nevertheless. But let me try again. Yeah, if source contains n or more bytes, thing will write to the data, so therefore the side there must be at least. Okay. String cat and string and cat, the functions return pointer to the resulting string destination. Okay. Let's try it with 4, because here actually we have the destination, which only has 4 bytes, and then we try to write 5 bytes. So we're expecting some sort of error here. Yeah, so as you can see, the problem is that here we only took 4 bytes of string 1 and string 2. Okay, so let's try it with 5, which is the length of string 1, string 2. Compile, run, and then we got what we wanted, but we are still vulnerable to buffer overflows on format string, right? So let's see what will happen if we don't allocate memory and just use the string pointer here. And okay, so we don't free and don't do anything. We just initialize a pointer to string. We just declare via a pointer to string, and then we concatenate the strings here. String 3 is use initialize. Okay, so what do you think will happen? Yeah, segmentation fault, as I said. We have to initialize our pointer. We can initialize wherever like this, and I believe C will accept this in most versions. No, so yeah. But you can notice that our error message telling us that it was initialized is actually it didn't show up anymore, but it's still initialized or string, right? So let's test if we initialize it, I don't know, with test 3. Okay, I believe it will break as well. So yeah, segmentation fault. So we have to allocate memory first, and then we are then able to use it to concatenate strings. Okay, so on sign n we set it to 32, and sign int, and we compile, run, and everything runs fine again. So yeah, here actually we can change this hard-coded 5 here to a string length of string 1 and string length of string 2. Yeah, so same result, but as I mentioned before, we are still vulnerable to buffer overflow. So how can we prevent that and avoid such thing? Well, we could write our own string cat function, so it would check if the string length of string 1 is greater than the length of string 3, then we abort a function, we return some error message, else, and then we perform the string concatenation. Well, since this video is getting quite long, I will end it here. As you can see, we only talk about 2 functions from, actually more if you count the versions with n, but basically we talk only about 2 functions from the string.h library, which were the string compare function and the string concatenate function, string cat. And as you have seen in the beginning of the video, there are many more functions which supervises us to manipulate strings, and we'll cover that in a future video, right? So I hope you guys enjoyed this video. Don't forget to like, subscribe, and comment. Ask me any doubts you might have, and see you next time. Bye.